Well, no, it does some weird proprietary thing. It's like a CMLJ something. All right. So deployment options. A couple things on deployment. You guys know what these little options up here do? Release versus debug. Anybody notice what was there? Okay. Now we go into the configuration manager. Debug, release, same deal. Whoop-de-doo. If you go into your Solution Explorer, you right-click on your project and go to Properties. You have all these additional properties on the project. These are specific to the way Visual Studio interacts and engages and deals with your project. So there's a lot of stuff under here. Assembly name, that's what your program compiles into. Depending on if it's a Windows or WinForm app versus a class library versus something else. The assembly name is the name. So WinForm app compiles CPU11.exe. You can change that to be whatever you want. It does not have to match the project name. So if you want it to be whether you're running ApplePie.exe, you put it in there. You don't have to touch anything else. The next time you build, it will generate whether you're running ApplePie.exe. Target framework, Visual Studio 2012. Targets by default, .NET 4.5. If for whatever reason you're running a different version out in your production environment, you can target lower versions all the way down to 2. What does that do for you? If you have machines that are only running .NET 2, this will do 2 things. One, it will strip out all of the newer features out of your development environment. It will hide link. It will hide generics. No, I think that bad generics are in 2. It will hide anything that doesn't exist in versions of the framework higher than 2. It will compile against 2, which means that it will run the most efficiently against 2. Pros and cons. If you're deploying an application that you want to have the most flexibility, you want to compile at the lowest level. Applications that you want to have the highest level of compatibility or flexibility or control, use all the new toys. Compile at the highest level. Client profile means that there are 2 different, I shouldn't say 2 different, there's a subversion of the framework. They figured this out starting in .NET 3.5 that you don't need all the web server hosting libraries on your desktop machine unless you're building websites. So why deploy all of those advanced web server features and all these other server-based technologies that are built into the .NET framework if it's designed to run WinForm applications on a desktop or a tablet or a mobile device? The client profile is a trimmed down version of the framework. You'll notice inside of the documentation that there are only certain pieces, only certain functions are available under the client profile. Other pieces are not available. So as you're building your app, and if that is a consideration, you may want to keep that in mind about the client profile. What else? Output type, Windows application, console application, class library. Those are the 3 output types. Generally, this is decided for you depending on the project template that you pick when you create a new project. Startup object, by default, it'll find it. It's the static void main, but you can set it alternatively. You want to put a fancy icon on your app, this is where you do it. The manifest, we'll get into in a moment. Assembly information. You want to stamp, sign, and seal your application and say it's yours and include copyright. This is where you do it. Version increments can also be defined there. That is for backwards compatibility with COM. You ever dug through the registry and you found that, I think it's like class ID or CLS ID key inside of the registry? Okay. Everything in COM is defined uniquely by a GUID. This is the GUID that uniquely defines your object in the .NET framework. So if you want to make it backwards compatible with COM, you have to have a GUID that's unique for your application.
We don't know Active Directory needs to do
The SIDS. Mm-hmm. So a GUID is a GUID. You know what that is. That's the reason it's generated, is to uniquely identify your application. One other thing that's good, and it's not, you don't see it so much with the applications, the executables, but you see it a lot more with the libraries, is that there's a space within the Windows folder called a GAC, G-A-C, Global Assembly Cache. When you deploy a DLL file into the GAC, you gain some things. You gain 3 things. You gain side-by-side deployment. Side-by-side deployment means that you can have version 1 of that DLL running on the same machine as version 2 of the DLL. It will understand that you have multiple versions living side-by-side. Even if they have the same file name, it knows, it looks deeper than just the file name and says, oh, this is version 1, this is version 2. So if you have an application that needs version 1 of that DLL, the .NET Framework will deploy that version to that application. If it needs version 2, it will deploy the version 2 app, or the DLL, and it will not use 2. Second, it's global, so it's accessible by anything. You don't have to put it in the bin directory or next to the executable. It's just you install your app and that DLL goes over there and you send it. The third thing is that everything in the GAC is compiled to native code by default. So if you remember, we talked about Java, and you have bytecode. So you have your source, you compile it into bytecode, which is that intermediate language code, and then you have a virtual machine that runs that converts it to native. Same idea with the .NET Framework. You have your source, compiles into IL. IL is then run through the framework itself and compiled into native code. When you deploy your DLL, I should say, when you compile your DLL in Visual Studio, you're getting a DLL that is nothing but IL, or intermediate language code. When you put it in the GAC, part of the GAC import process is it takes it, runs it through Visual Studio, catches all the bytes on the back end, and stores the native implementation. So it's actually a faster, or it becomes more efficient for the computer to run. Now, you don't want to always load everything in the GAC, but there is that functionality. What kind of things commonly go into the GAC? All of the standard .NET Framework DLLs are in the GAC. A lot of third-party components like Oracle, ADP, or ODP, Oracle Data Provider, that loads into the GAC. And they put them in the GAC because they don't want to have you, as the developer and as the user, deal with compile time every time. You want to use a native compiled version of that library. The GUID helps identify uniquely that item in the GAC. Build. There's that debug thing again. This is where you'll notice the difference, debug versus release. You have defined debug constraint, define trace restraint, prefer 32-bit, platform target, use unsafe code, optimized code, warnings, and output options. This is the debug set. When you flip from debug to release, the debug constraint is dropped. Optimized code is checked. When you run your code in debug, every variable and every function gets what's called a debug pointer. So when you're actually debugging your code in Visual Studio, Visual Studio is not saying, oh, this is line blah, 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 and then goes and finds that in the source code. It's not looking at the execution code and then finding it in the source code. There's a PDB file. definition of PDB escapes me, but what that PDB file does is it is the symbols file, they call it. And basically it's the go-between. Executing byte XYZ exists on line 192. 192 in the source code file is this line. So that's how when you debug, that works back and forth. When you optimize your code, those symbols and those marker points for debug are lost. So the ability to break code, inspect variables, all that stuff gets optimized away when you optimize your code. The gain is performance. You don't have to be able to inspect every variable. Things get optimized away because the compiler is smart enough to know there's certain performance enhancements that can happen, and it can actually optimize away certain variables depending on what they do and how they function in the code. So by optimizing that code, you're actually providing additional efficiency or performance. Build events. What do you want to happen before you build? What do you want to have happen after you build? Debug. This is where you can control what happens on debug. Start the project, start an external program, start a browser URL. The last one you see in a lot of ASP.NET apps. Start a particular URL, start the current page, so forth. You're building a console application that takes command line arguments. You want to debug those arguments. You can put them right here. So put your slash whatever. It'll pass it when it runs. You don't have to launch it and then hook to it and try to debug it. Just put your arguments right here. Set the working directory, you can do that. You can enable additional debuggers. So obviously, Visual Studio hosting process. Debugging is enabled by default. You can enable native code debugging. So if you have the symbol file for some native code, so if you're running COM and .NET side by side. One that I've never had great success with, but you can do, is enable SQL Server debugging. So if you have the debugging tools enabled inside of your SQL Server instance, you can actually go in and put breakpoints in your queries, and break in your queries just like you would in SharePoint. All right, resources. You can add embedded resources you want to embed into your program. Images, sound files, text files, strings, whatever. The services, I won't even get into it. If you have an interest or a need for it, you can read it. Settings, additionally, you can define settings and embed settings into your application. This will spin off a new file that's a .settings file, and then you can kind of write it along. So you're kind of abstracting out from the code particular settings, but it's a method or a way of storing the settings for your application. Reference paths. If you have resources that are in different specific paths and you need to reference them, that's where you define them. Signing, we'll get to in a minute. Security, we'll get to in a minute. Publish, you can talk about now. And then there's code analysis, where you can actually let Visual Studio do an analysis of your code. It determines level of complexity, level of maintainability, and some other elements. Basically, it looks at the interrelationships between your objects, the inheritance, the repetitive code, things like that, and it tries to do some sort of analytics to determine how maintainable is your code, how reliable is your code, what's the statistical possibility that your code will break, and it tries to do some of that analysis for you. So it's kind of fun. It also gives you line counts, so if you're all about line counts, that's fun. All right, so publish. All right, well, before I get into that, whenever you deploy, you always want to do a release build. ideally you always want to do a release build. It's more efficient, more effective. It's a better build than a debug build. But if you want to debug while you're in production, then obviously release the debug build, and then you can do remote debugging and things like that. If you go back and you right-click on the project, open a new folder, you got the bin directory, right? Well, now you have a debug folder where the debug builds go, and you have a release folder where release builds go. And you'll notice some things. You'll notice there's the exe, the executable. There's the config file. So the app config gets converted upon build into executable name.exe.config. Visual Studio automatically knows that when you launch that exe, that config file needs to be processed and run with it. If a file is not named the same as the executable, it gets dropped or skipped. There's the PDB. There's our symbols file for debugging. If you include the PDB with the production deployment, when exceptions occur, it will spit out line numbers. If you do not include the PDB, you'll get those really big cryptic memory address style exceptions. So it'll give you the stack trace, but instead of telling you what line it's on, it simply says this method was called at this address. Some would say, so what's the pro there is, if you're releasing this out into the wild, you don't want people to necessarily know what line of code you're running against. The VS hosts, those are useless. Don't worry about those. Those are used for when Visual Studio is running and debugging your application. And then it packaged up my MDF because I added it to the project. So these 2 or 3 files are what you need. If we had DLLs that we were referencing that were not part of the GAC, those would get sucked into here as well. If we had external resources that we wanted to copy, they would come across as well. If we had additional class libraries in our project that were dependencies, those would get compiled and sucked in here as well, and they would sit side by side with the executable. All of those need to then be shipped off to make the product function in production. 3 types of deployment. Xcopy, click once, install shit. Xcopy. Xcopy is the most simplistic form of deployment. It's the highlight, copy, paste. Xcopy is a command from DOS. That's where it comes from. That's basically Xcopy everything from this folder. It copies folders, subfolders, and so forth. So they call it Xcopy deployment. So essentially, copy, put it on a thumb drive, give it to somebody, they copy it to their machine. Unlike traditional Windows applications, .NET applications are kind of modular and isolated. So wherever they land, as long as all of their dependency components, meaning the DLLs that it needs, are either in the GAC or in the same folder as the exe, the program can be simply copied and moved anywhere. You don't have to do registration of DLLs like you do with COM. You don't have to do all these weird things that you would have to do with traditional Windows applications. So it definitely has its benefits. Come on. So that's Xcopy. Properties again. Okay. Click once. Click once is a concept that was developed by Microsoft that enables over-the-air, web-based application deployment and installation. The idea was make it ridiculously simple for someone to go out to the internet and download and install an application, assuming that things are in the right place and security is set up correctly. I don't know what that means. Has anybody ever downloaded Google Chrome? On a Windows machine specifically. You ever notice how it does this really weird thing where it gives you a button that says download and you click it? And sometimes instead of it giving you an installer to download, it pops up this little window and says, we're now installing Google Chrome, and it just whoop, goes across the screen. That is Click Once deployment. This idea that you don't actually have to download a file. Instead, you click a link, and the .NET framework kind of kicks into gear and says, oh, that's a .NET application that is Click Once enabled. So by clicking that URL, the framework goes out and downloads the installation and installs the application for you automatically. With Click Once set up correctly, not correctly, but using updates, when you set up publishing updates, you can publish new versions of your application up to a web server. So what are the prerequisites? What do you have to do in order to do Click Once? You need to have a web server or some sort of shared space to publish your document to, your application, your application. The application gets published, and then you get a URL. That URL, you click it, it then enables Click Once, and you start to download your application. Click Once is not, I shouldn't say that it's not easy, but it is tedious to set up. There's a lot of detailed articles on MSDN. There's information about it in the textbook. I'm not going to go through all of it tonight, but I want you to be familiar with these. With Click Once, you can say auto update. So every time the application by the user is launched, Click Once jumps into gear, and it will actually go out to that server and it will check the manifest that's posted out on the server and figure out what version's on the server. And if a newer version of the application is out there on the server versus what's running on your machine, it'll automatically go out and download the new version and install it before it launches. So think of an enterprise environment where you've built a Windows-based application that you're constantly working to improve. Instead of making people go out and download the installer and do the install and doing the upgrade or building a custom update engine for your application, Click Once deploy. Within the enterprise, the app is then downloaded on people's machines. You continue development and work on it, publishing new versions as they come out. And then when people come in the next day, they launch the app. The first thing it does is it goes out and downloads the newest version and installs it automatically. Right, but Firefox isn't going to update it. This is all built into the framework. You don't have to code your own. Firefox, Chrome, and there's a lot of apps that do it now, but they're basically rolling their own update. This is built into the framework where you just set the right pieces in place and it happens automatically. Okay? So what's required to make this work? Signing is a big piece of Click Once. Signing means having a authentication certificate. So does everybody know what HTTPS is?
Security.
SSL, right?
Yeah.
Websites.
Security certificate.
Right. Same idea here is that there is a certificate that confirms that this application is legitimate, authentic, and secure. It also directly binds the application to its developer. At least in theory, that's the goal. So that this application cannot be, maliciously changed or messed up in some way. So this certificate is actually embedded into the Click Once deployment and is the signing that says this application is going to come from this server is owned by this company, therefore this application is owned by this company. Everything lines up. It's a good install. It's safe. So you have to set up a server certificate. You then add the certificate into your application. You have your assembly signed using that certificate. If that certificate is specific to your enterprise, then you want to store that certificate on your certificate authority server within the enterprise. Otherwise, you have to go out to GoDaddy or Network Solutions or whomever and actually pay the $100 or a couple $100 a year for a certificate. Security has to do with trust level. What is this application able to do? What is this application requesting to do on your computer? You have full trust, which means this application can do anything and everything on the computer. Access the hard drive, add, remove, delete, or add, move, rename, delete files. It can make registry changes. It can make system level changes to devices. That includes your monitor, your keyboard, mouse, your network adapters, all of these things, and for profile-specific changes to your user on the machine. Partial trust means maybe I'm downloading an application like Spotify or Pandora or TweetDeck. The application technically needs very little to no resources on my local machine. It just needs to be able to run and connect to the internet. Partial trust says, I just need to do these few things. These are the things I need to do. They need to be able to be installed. I need a little bit of hard drive space out of the temp directory, nowhere else, and I need to be able to connect to the internet. Install me with partial trust. The .NET Framework will then build a sandbox environment around the application. And if the application tries to break the contract of that partial trust, it will throw an exception and terminate the app. A lot of large third-party hosting companies run all web applications in partial trust mode. You got a lot of apps running on one server that's owned by a big company, potentially a server farm. You do not want that web app trying to go in and whack files out of the Windows folder on that server. You want it to run in a sandbox environment and only be doing what it needs to do with the web app. So, you have to define the trust. Setting applications at full trust often forces the user to accept the click once deployment. So if you click once deploy, they click the link like Google. You click it, you usually will see a small box come up that says, this application is installing with full trust. Do you want to allow that? Now, things have changed since Click Once was first designed. So things function a little differently on Windows 7, Windows 8 machines. Now you have the UAC there, and that little bloop thing that pops up that makes you say yes or no, or okay, or continue. That triggers full trust versus partial trust. Full trust, you get the bloop, the UAC prompt that makes you want to go in and say yes or no. Partial trust just installs with what it needs and assumes that it does not need full access to the machine. So what that feels like is a little different now than what it was 5 years ago. So once you get all of these components in place, you can go in and publish. So you define the location, a folder, an FTP server, a web server that you want to publish to. The installation folder URL is different. You can set up your application files, your prerequisites, your update schema. Do you want it to auto-update every time a new version is published? And then there's additional options. You can have the application run only when the machine is online. So maybe for security purposes or something unique about the deployment, you only want the application to run when the machine is online. What does that mean specifically? When it is in network. So the program needs to be able to actually call back to the home server that the Click Once was configured for. This program can only be run within PNG on PNG's internal network. If I'm a PNG employee and I take my laptop home, I try to run this application, the program only runs within the PNG network. It has to be able to see the deployment server and be able to run. It also, depending on how you set it up, means that it can only be launched from the website link. Even though it's installed locally, it's not available via the start menus. These local components are installed, but to launch the app, you must click the web. You can change your publish versions, and as you publish, you can have it auto-increment. There's a publish wizard, which will walk you through some of the setup, and then obviously publish now. So once you have all of that set up in place, you can just go in, say publish, and boom, it'll do it. I knew it was going to take 2 hours to get through this. All right. Any questions on that? I'm not going to be able to cover Install Shield in 15 minutes, and I started doing it before we got into the lecture, and you'll see why in a minute. Okay. The third option, and you need to understand, Install Shield is not a Microsoft technology. Install Shield is a third-party technology. Visual Studio has a light version of Install Shield built in that will help you go through building an Install Shield installer. If you want to do the full-blown version, you have to go pay the Install Shield people to use it. There's another version of deployment that actually is built on Microsoft technology, and I did not see it in here. So, if you right-click on the solution, and say Add New Project, under Other Project Types, Setup and Deployment, there is the Enable Install Shield Limited Edition. I hit OK. It took me out to the internet and gave me this thing. So I went through and I filled out this little form. And then it gave me this. I said, thanks. Take the serial number, download Install Shield, install the add-on for Visual Studio 2010, 11, 2010, 12, and 13, and then use this key for the limited edition. Walks you through the installation, tells you what you can and can't do. It looks like all you can do is do Windows 8 start screen icon pinning. You're allowed to install on Windows 8 in 2012. You're allowed to do 64-bit apps. And you can install Windows, or your app on a Windows machine. I'm not sure how big this download is. So what will happen is you'll create this project, and again the textbook goes through it in more detail. You'll create this project, it'll add it to your solution, it will then launch into a wizard, and it will walk you through, similar to what ClickOnce looks like. It'll walk you through setting up that deployment. What project or project components do you want to include in your installer? What's the default folder you want it to install to? What settings do you want to default? What settings do you not want to default and prompt the user for? And you define all of that. A very simplistic install Shield application if you've ever downloaded just simple open source apps. They tend to just ask a few basic questions. This is what the app is. Where do you want to install it? Tell it. You hit next. It installs. It says, okay, I'm installed. And you click finish. It's done. So if you don't have complex setups like, where's your SQL server? What's the SA password? I need to mount this MDF file. If you don't have all of that to do, your installs are pretty simple. A piece that's built into Windows, and I'm surprised the book doesn't talk about, is called Windows Installer. Often they're also referred to as MSI files. I think there's an add-on that enables the MSI installation package or project type. The MSIs are actually pretty neat deployment mechanisms, like basically similar to what the install shield does. But with the MSIs, you can actually take them and push them out via group policies. So if you're managing an entire network of machines, instead of having to go machine by machine and install it, you can set up what's called a group policy. So when the person logs in, it simply pushes the installation down to the machine, and you can even set it up to do a silent install. And then it just installs it quietly in the background, and then the user has the app at some point once the installation is done. So if I do add new project, alright, so I'm not going to be able to show you install shield. No, you're not working for next week. Alright. Any questions around these ideas of deployment? There are a lot of different deployment technologies out there beyond these three. Obviously, Xcopy is the most simplistic, most direct. Who's the guys that make Winamp? Nullsoft. I know they have an install shield that a lot of open source apps use. I've never had any experience with it personally, but a lot of people use it, so it must not be that bad.
Isn't that part of like Winamp or something else?
Nullsoft is a company that did Winamp, yeah. So they have their own little install shield that they use. There's a few others, I just can't think of their names. So there's a lot of options for deployment. From my experience, most of the applications that I'm running, I'm either doing click once or Xcopy. Again, it depends on where you're developing and what type of environment you're developing. If you're developing, commercial production applications like Microsoft Office or Adobe Photoshop, you're probably using something like Install Shield or the Windows installer. If you're doing in-network enterprise deployments, then you're probably doing click once, or you're just putting it on a shared somewhere and either having people do Xcopy deployments or whatever. The Windows installer is also a good one. And a lot of people in the enterprise thank people that actually do MSI deployments. So, question? Thank you very much. That's all I got. Next week we'll talk about Windows 8 apps a little bit. I will definitely not go terribly long. So, MDI, SDI environments. SDI environments are single, I forget exactly what it means, something to the effect of single display interface versus a multi-display interface. The idea is when we build applications that are single windows that kind of work intercollectively, we have a window and then we pop up a dialog window, or we launch a second form and they all kind of just float around on the screen together. Those are SDI environments where each form basically is functioning independently, but it runs within the overall application process. MDI environments, you probably are most familiar with them in applications like Microsoft Word, Microsoft Excel, Visual Studio. Those are MDI environments. So what makes them MDI environments? The fact that you can have toolbars, dialog boxes floating around the screen, as well as the ability to have multiple windows that all reside inside of a master or parent window. So having these kind of nested window environments where everything is all kind of contained inside of one giant window, and then inside of that one giant window are all these little tiny child windows. So you're not just, you don't have forms floating all over the desktop. They're all kind of consolidated and kept together. That's the concept I want to show you tonight. That concept will probably take me all of 15 minutes to show you. It's not that complex. It's just a matter of knowing what properties to set, what properties to use, and how to make all the pieces kind of fit and work together. The other piece that I'm going to talk about tonight is chapters 25, and I'm going to cover it in very high level detail. I'm not going to go into all the intricacies. If you're interested, they are in the textbook. But I'm going to introduce you to the 3 deployment methods. You have Xcopy, click once, and then you can actually do an install shield deployment, which is the most traditional way of, here's the setup file, run this setup, and it'll install your program. You can do all 3 of those within Visual Studio. And I'll talk about the pros and cons of each, the good and bad, and then I'm going to at least get you to understand how do I get to that point of doing a once-click install shield or just a basic Xcopy. Okay? So all of that should probably take me about an hour, hour and 15 minutes. So hopefully we should be done by 7:15, 7:30 at the latest. Depending on how long it's taken me to get to that, I'll probably stop around 7 or quarter till 7. We'll still take our normal break, and then we'll jump back into it. So we'll see where we get. All right. So doing MDIs is ridiculously simple. You have a form, any form basically, and you set a property is MDI container. You set it to true. Now I recommend only doing this to one form. You could do it to more than one if you have the right reasoning, but in a normal application you have one form and you set it as your MDI container. So you look for the property is MDI container and you set it to true. What I'm also going to do is I'm going to rename form 1 in my project and I'm going to call it parent. Visual Studio will say, you're renaming a file. Do you want me to rename the rest of it? And I'll say yes. So this form is now our container. So we'll just say this is the CP Week 11 app. My start position, I'm going to set it at center screen, and I want it to maximize box true, minimize box true. Where's the default size? Windows state maximized. So what does that mean? Run the program. It will launch my MDI full screen. I want this container to be a full screen window. Because what are we going to do inside of it? We're going to drop forms or open forms inside of this window. So what kind of application are we going to build? We'll go through and just do a real simplistic one that incorporates let's see, what do we do? We'll just do something like a real simple like store application. Okay. So first thing that I'll do is I'll go into my toolbox. We'll add a menu strip. So file. If you remember, if you use the ampersand in front of the letter, it makes it a hotkey. And then this will be our exit. We'll say inventory, sales, help. Say add item. Edit item, manage
new invoice, new quote, new purchase order. All right. So I'm going to go ahead and I'm going to create 3 forms. One that manages inventory, one for new invoices, and I think that should be sufficient for the example. So I'm going to add a new Windows form, and I'll call it inventory. I'll add a second form, and I'll call it invoice. And I'm just going to leave them as they are. I'm not going to get into too much nitty-gritty with them. So if we're going to do an add item, let's get these out of the way. So we've done this work in the past. So you pop up a new form. So you say inventory new form equals new inventory, right? And then we say new form dot show. If we run this, inventory add item, we get our little inventory window. Thanks, Windows 8. But our forms are independent. So this is still kind of an SDI application. They're not connected. If we mouse over this, we see both forms independently. We can then actually click on this and minimize it, but it minimizes into the task tray instead of minimizing into the window space, the MDI space. So we want to be able to attach or associate these. So before we launch show, we say new form dot MDI parent, and what we're doing is we're setting the parent of this form. So the MDI form, the parent form, it's funny I use that term, right? Is launching a child form. It's creating an instance of that form, and then it's going to launch it, it's going to show it. But before we show it, we want to say, by the way, this form is owned by me, the parent form. So the new form, and then the MDI parent of that new form is this. And the reason it is this is because this is referring to parent, the parent form. So the keyword this always refers to the class itself. So this refers to the active parent form, the MDI form. So now if we launch inventory, add item, it still launches the window, just the same. You can still drag it around, but it now lives inside of our MDI container. If I take this out of full screen, or out of maximize mode, there's our window, but he's stuck inside of there. I can maximize it. So now it's maximized inside of the MDI. If this was Word, then that would be our page. We can manipulate and add and do whatever we wanted to do. We can treat it as a child window and actually float it around. We can minimize it and it docks into the bottom of the MDI window. So everything is now contained inside of this MDI container. If we mouse down here, we only have one app running. We don't have all these different windows that are all hanging out together. If we minimize, everything gets minimized all at once. So we now have this contained shell of an application. So sales, new invoice. We'll say invoice, new invoice form equals new invoice. New invoice form dot MDI parent equals this. Again, referring to that parent form, because all of these event handlers are written inside of the parent form class. And then we say new invoice form dot show. launch again. There's the inventory. And there's the invoice. So these kind of run mutually exclusive to one another, but they're both inside of the MDI space. I can maximize one, and it maximizes them all. I can control tab, and if you look up at the address bar, you'll see where it says inventory. Now it says invoice. So I'm actually toggling between those two windows. We can add to our menu bar window, and we can do cascade, horizontal tile, vertical tile. So how do we facilitate this? Part of it being an MDI form, there's a method called layout MDI. And then you pass it an MDI layout enum, which is arrange icons, cascade, tile horizontal, or tile vertically. So this one is our cascade. So we'll call cascade. Call the layout MDI method, which is the method of the parent form again. And we'll say MDI layout dot tile horizontal, layout MDI, MDI layout, tile vertical. So we'll load inventory, load invoice. We can actually launch multiples of these if we wanted, because we're just creating a new instance every time. Let's say cascade. Tile horizontally. Oh, let me cascade again. Tile vertically. So it's using the same algorithm, so it's all coming out the same. But we could launch a new one, invoice, and say tile vertically, and it'll make adjustments. The arrangement that it's doing, I did not program it. Yes. Yes. So if we go back to the code, I have these three menu item clicks calling layout MDI the method and passing in tile vertical, tile horizontal, cascade off of the MDI layout enum. That's what's triggering that layout.
These are the words, therefore you can replace the words with something else. So these are
These are the words. These are part of the framework, the .NET
okay, so you need to use this.
Yes, because they are part of this enum. I'm just using the same words or similar words from the UI so that there's consistency. I mean, those are common terms. So, you go into Visual Studio, you drop down, you have new horizontal tab group, new vertical tab group. No, they don't have cascade, but older apps had the cascade option. So conventions are conventions for a reason. This is one of the things I always say as a programmer. So you want to make your program as easy to use as possible, so you want to be as consistent as possible with other applications. People always assume, or they should, that under the edit menu they will find what? Undo, copy, cut, paste. If I go to edit and all I find is save, that bunks convention to me. If I go under file, I want to be able to find new, open, save, exit at minimum. So don't start putting it under help. Those kinds of ideas. So these conventions are conventions for a reason. Okay, so this doesn't change the way forms work and the way the forms interact. Yes?
Is there any way to set it so that the forms can't overlap
say you open a new inventory and a new invoice, that when they open, they're next to each other rather than one on top of the other?
That's a good question. I think aside from probably actually doing the calculation to open them side by side, there's no like simple setting to make that happen. So you would have to do a detection and then manage that detection. So one thing that's there that I kind of just glossed over. So we're going through and we're creating a new form. We're saying this is the parent, and then we show the form. If we go back to this dot, there is an MDI children property off of the parent, and it's actually off of every form. But that provides for you an array of all the active forms that are owned by the MDI. So if you wanted, you could iterate through that, see if there is an inventory form currently in the collection. You could do some logic like, if there's an inventory form, don't launch another one. Bring that one to focus instead. Or you could detect, is there an inventory one? No. So you'll want to show it. And then you can also say, is there an invoice one? If there is, force some sort of layout adjustment so that they come up side by side. Does that make sense? Okay. So what I was going to say is the interaction between the forms does not change. What you actually gain by doing this with the parent, with the MDI, is that you now have a centralized parent form that can kind of be your traffic cop between your children forms. So before, we would kind of facilitate doing that with a master form. So that master form was the first form that launched, and then we were doing our midterm project of adding a doctor and adding prescriptions and all of that stuff. You would have kind of this master form, and then you would launch these child forms off of it. Your dialogues, you do show dialogue. And then that master form would kind of act as the traffic cop. So the child, you would call a method, the child form would launch as a dialogue box, you would do some action, and then we would capture that dialogue event, and then we'd have a public property, and we'd pull a value out of that child form and store it somewhere. Same concept can still be done here with the MDI. What you gain is that the MDI then has control over all the forms and is interacting and dealing with all those forms together. So when you drop down and say add inventory, that add inventory then triggers, okay, there's this form here now. You then, once the form closes, you then can capture that and then move forward and continue to do things. When you do a show dialogue, you actually get an exception. You get the exception because dialogue boxes, by design, are designed to be top-level forms. They want to take control over the entire space. They want to be on top. They want to be the only thing they can be interactive with. Within an MDI, you cannot set a form as an MDI child and then say, make it a dialogue box, because it kind of bunks the whole concept of this form coexists with these other forms. It wants to take control, so it actually throws you an exception. And the exception says, the form is not a top-level form and cannot be displayed as a modal dialogue box. Remove the form from any parent form before calling show dialogue. So that's just something to keep in mind. In the past, what we've done is we've always used dialogue boxes to facilitate what we're doing. Using an MDI layout, you can't use those dialogue boxes because everybody kind of coexists together. So what you may be wondering is, okay, so before what we would do is we would say, add doctor. You drop down, you say add doctor, and it would do a dialogue box, prompt for that user to add the doctor. Upon prompting, it locks the event, the click event, this click event that says show dialog, it locks there. And it goes off and it launches that dialog form. You do some stuff inside of the dialog form, and then once you hit OK, it then comes back to here and it continues to execute. When you call show, unlike show dialog, you're actually executing what's referred to as an asynchronous process. You say show the box, and it goes OK, and then it walks away. So for example, if I come in here, let me turn this back to show. Let me do it this way first. So let me comment this out. And then I'll do message box.show. Dialog box closed. So the idea here is create a form, show it. It's not an NDI association, it's independent. Show it as a dialog box. Once the box is closed, I want to say dialog box closed. So if I run inventory add, I do my thing with this form, blah, 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 blah. Fill it out, hit OK. Dialog box closed. The reason for that, and the reason it flows the way it does, is because if I put a breakpoint here and a breakpoint here, run it again, or I'm sorry, launch it again, we hit new form.showDialog. It prompts the new box, and that thread stops executing. It actually waits. And it waits until this window is closed. Once the window closes, it moves on to the next line of code and it executes, which gives us the message box. So I'm going to turn this into, stop debug. Turn this into a child form. I can't do show dialog, I just have to call show. Otherwise I get the exception. And I run again. Immediately, I get that pop. I get that message box showing. I didn't close the form yet. But the form is now running out of process of the NDI map. So it calls the box, it says, okay, box is launched, spins it off, and then it goes on to the next line of code, which is dialog box closed. So what do we want? What is our goal here? We want to know when the box closes. Because at the point at which the box closes, we know that there's a high likelihood that we should act in some way. Maybe we want to capture that inventory item that was added and store it in the database. Or maybe we want to cause a process. You close the inventory box and now an email is sent to receiving. I don't know. Something like that. The way you can do that, you stop debugging. You can say new form dot. And you know how we wire up these event handlers all the time? We go in, we double click, and it creates a method. You can also do it in code at runtime. So by saying new form dot, we have access to all these properties, but all these little guys with lightning bolts, those are events. And there's form close events. Now there's form closing and form closed. The difference is, before the form closes, this event is fired. Form closing. When the form is closed, it's already disappeared from the screen, this event fires. Is there a real difference? That's up to you to decide. You decide when you want to handle the event. In my case, I want to handle the event when it's closed, because I want to have that message box pop up. All right? So how do you wire up into this event at runtime? So it's new form closed, that's the event. The syntax is plus equals. The reason it's plus equals is that what you're doing is you're adding a method to be called when the event fires. So just like when you have, int I equals 0, and then you say int I plus equals 1, you want to take the value of I, 0, and add 1 to it. Then you do plus equals 1 again, and then you're taking I, which is now 1, and adding another 1 to it. So it's the equivalent of doing I equals I plus 1. Same idea. We're taking whatever event handlers are currently wired up, and we're adding another method to be called when the event fires. Now, this is so common that Visual Studio helps you. It says, oh, okay, new form, form closed. So you're going to create an event. You're going to handle this event when it happens. So at the moment you do plus equal next to event, it says, oh, do you want me to create new form underscore form closed? The same event method signature that we get every time we double click on something to say go ahead and create a click event for that. It uses the same syntax. And then it says, okay, I've now created this kind of template or this holder, and it says press tab to generate the handler for this class. So it is assuming that this is going to be a method. It's going to exist. It's detecting that the method doesn't exist, and it's saying if you push tab again, I'll go ahead and create an event handler for you. So now when this event for this new form happens, this method gets called. And what do I want it to do when it gets called? Show that message. So let's run it again. Inventory, add item. So it's going to say new form.show. It then goes ahead and launches the next line, which is new form.form closed. Wire up this event. New form closed. If I mouse over that and I hit F12, it's going to jump me into that method, that function that was just created. So now the form is here. It's inside the MDI. It's locked in there. I'm going to close it. Upon close, it kicks off form closed. The form itself, the new form, kicks off the form closed event because we closed the window, because we closed the form. That kickoff, the mechanics are, okay, you close that form. There's a series of methods that may be wired up into that event. Go ahead and run them all. Call them all in sequence. Now the sequence isn't always guaranteed. They'll tell you that in the documentation. Every method will get called, but it may not get called in the order you think. It will just call every method, so that's something to keep in mind. But it calls new form underscore form closed, which will then prompt for our dialog box. Fancy. So what value does that give you?
You just say, do you want to close the form? And yes. Would it be more clear?
You could. I mean, it depends on the flow of your application and what you're trying to accomplish.
Because that's kind of ambiguous.
I'm trying to show you the process. I'm not trying to show you how to code it for your scenario. So you're saying, so what I'm getting at is this. So let's go concrete. Alright, so what does this do? We have two boxes, price and name. Those boxes are now to create a new item. So we have a new inventory item class. It has two properties, name and price. Inside of this, we have a decimal. We attempt to parse the decimal from the text. If it's successful, we then create a new item with the text name and the decimal price. We store that in the property of this inventory form in a public property called saved item. If the parse fails, we have a message box that says invalid price, and then we just return back to the inventory form. We could go as far as saying and string is null or white space txt name dot text. F12 public. So inconsistent accessibility. This form is public, this property is public, this class was not set as public. So inventory item, name, widget, $29.95. If I forget the name, I get the warning. If I put a bad price, I get the warning. Together, it works. Now, what could we do with that? What can we do with what we have here? So we're adding a new inventory item. You have two choices. Create another class. Oops, it's not at all what I wanted. Inventory item repository. Public static. So this acts as the storage place for inventory items. So that could be a database, that could be a text file, that could be whatever we want it to be. For me, for right now, it's just going to be this list. So prop, lists, inventory item, items, return items, structure, items equals new that. Public, void, add item, inventory item, items.add, item. So within the inventory form, we could simply go in and we get down here, we have the saved item. We could then call out inventory item repository. Oh wait, I didn't make those static. So this is a static constructor. And this is a static private field, static public field, static method, static method. So I made the class static. A static class means that everything inside of it must be static. So that's the given of all this. The reason I made all of the properties and methods static is I don't want to have to create an instance of the inventory item repository. I just want to be able to call that class and do inventory item repository dot add dot remove dot items. if I didn't make it static or didn't make the methods and properties static, I'd have to say inventory item repository repo equals new inventory item repository. That being said, it would probably make more sense to actually not make it a static. Because, well, it'll get into a whole other thing. So that's why I made it static. So then from here I can just say dot, and then I get all my methods and properties. I didn't have to create a variable for it.
Static just replaces that then, essentially.
Static says project it out and make it available without creating an instance. So it kind of lives in this shared memory space. So the compiler implicitly creates an instance, and then everything there, all the properties and stuff that are static as well, they just kind of get this memory space that's carved out for them automatically.
How are you going to say that you shouldn't have
What I was going to cover next week in more detail was this idea of creating interfaces. So what we could have done is we could have created an interface for inventory item repository. So what is an interface? An interface is basically a blueprint. It says whenever you create an instance of a class, this class has to follow that blueprint. So we could create a blueprint for our inventory item repository, and then we could create different classes that implement that in different ways. We could create one that does this, where it just has a list in memory, temporary. We could create one that adds and removes from a database. So when you call add, you pass it the object, it takes it, packs it away into an insert statement, and puts it in the database. We could create an instance of it that stores it to a text file, does comma-separated values. We could do an instance that passes it off to a web service and stores it somewhere in the cloud. By creating that interface and by making it an instance, you then can create different instances of the inventory item repository that have different pieces of functionality. A SQL instance, a memory instance, a web service instance, whatever you wanted. So doing this is actually a very short-sighted approach. You get a lot more flexibility when you start doing the instances and the interfaces, and you actually treat everything as an interface, like we did a little bit in the ADONet stuff. So for this example, it's not worth the investment, but that would be the reasoning. So we can say add item, saved item, and call close. So, kind of to your point, Adam, why not do it all in here, done with it kind of a thing, and prompt, are you sure you want to say? In this flow, it doesn't make sense to prompt them, are you sure you want to say? They click say if they want to say. If they hit the X, then you would want to capture that internally and say, well, time out, you're trying to close. Upon form closing, you want to handle that event and say, hey, I noticed you're trying to close this box. Do you really want to? Yes, no. Because they're clicking save, in this case, we would just handle it. And we can actually, this idea of separation of concerns is, do you really want the MDI to be handling this step of the save? You want to put that responsibility on the MDI to manage. Every time a form closes, it needs to do the cleanup. It needs to capture that data and do what it needs to do. Or do you want the form itself that's supposed to know the most about that data type, inventory item, do the final cleanup steps? Okay. So in this case, it goes ahead and calls add item to the repository and passes the new item. And then we can close the form. So from here, this is irrelevant. That form closed, we don't need it. If I go in here and just add a breakpoint, I can go to my watch You can say inventory item repository dot items. There is one item in the repository. That item is my widget for $29.95. So now that it's in a centralized place, any other form could access it. Trying to think of a really good concrete example where you would want the forms to talk to one another. All right. I'm going to go ahead and stop since it's 7. You may find, as you're going through your senior design project, you may find an instance where there's a workflow where you may want your senior design, your final project, or your senior design, where you want. So I'm thinking of a real world scenario. I go sales, create quote. I'm now wanting to create a quote for an item that doesn't exist in inventory yet. So instead of having to close my quote or step away from my quote, I want to be able from within the quote to say, add new inventory item. So I want it to then, so I have my quote, and then I want to launch that new inventory item screen so I can add a new inventory item so I can add it to the quote. The quote form is going to want to know when the new inventory item was added so that it can then capture that inventory item that was just added and save it or add it to the row in the quote. You follow what I'm saying? You have the quote, you say, you type in your item, you drop down and go, oh, I haven't put in widget X yet into the inventory. It just came off the truck today. So I want to say add as a new item. Launches the add inventory screen, I put in widget X, $199, and I hit save. That process that we just went through is still the same process of adding the item into the inventory. Verify the name, verify the price, create an instance of the object, put it in the saved item property. This is actually somewhat irrelevant now, but then we say add item. We've now put it in the repository. It's saved, and then we close the form. How does the quote form know when that inventory item has been added? It can wire into the form close. But what if you have 3 quotes running at the same time and they're trying to wire into the form that's the child form of that quote and so forth and so on? And what I'm getting at is that you can actually create additional events off of these forms, off of any class for that matter. And you could have an event that specifically says inventory created. So then the quote form can wire into that, and then you can actually project to the quote form, here's the new inventory item that was created. And it can then take that item and add it as a row to the quote automatically. So the whole idea of user experience and making it fluid and making it part of their real work process instead of making your application clunky and difficult. Sorry, my quote's not right because I have to go and add the item, so I have to jump in here and create the inventory item and I save it. Then I have to go back and create the quote again and then add the item now that it's in the inventory. So how do you wire up that kind of experience that's smooth and fluid to the user? So as you build your application, that's always something to keep in mind is it may make sense to you, but is it smooth and fluid to the user that's supposed to actually be using it? Because at the end of the day, a programmer is not using this program. Someone that doesn't know how to program most likely is the one using it.